Hello guys, Cyprien from F here for all. So in this video I'll show you how to create a simple plate, then we'll see how to mesh it. So nothing fancy here. And then this will be the mesh, and then I'll show you how to go into YACS and to create a small automation like this one, which will allow you to automatically parameterize your geometry and your mesh and to generate automatically like that an automation that can remesh with certain parameters of the geometry or the mesh. And that will be the first video of a series in which I will show you the full automation going from geometry meshing, and then in the next video we'll go with simulation and post-processing. So let's go and start this video tutorial. And before we start, if you like this series of videos that I'm doing, please support the channel, please like this video. This really helps me to create new videos like that. I really got a lot of feedback from my subscribers telling me I want to see how to do this in the comments, and I'm just making the videos for them. So this is really helpful if you can support the channel. So let's start and let's create a folder on my desktop. So call that the YACS example. It's a general bad practice to create stuff like that on your desktop, but anyway, that's just for the purpose of this example. Okay, and now I have to open Salome. So let's search for Salome Maker. So it is the 2018 version that I have installed. And by the way, you see that I am on Linux, and this is important because if you want to follow this tutorial, it is tried and tested on Linux. I didn't test it on Windows. I'm not fully sure it will work. So let's start by creating the simple model before automating it. So let's go into the geom module. Let's create a simple plate. You know, don't need to make some things complicated for the first example. And I'll go with a plate of 500, 500, and 4 in thickness. It will be a very thin plate like this one. Okay, and now I will have to define some groups. So let's define some groups. So create the group, and I'll create one group for the volume like this. So I'll call that volume. Then let's create some surface group for each of the 6 surfaces. And I will call basically those groups with the minimum and maximum of each. So for example, this is Z-axis. So this face here will be the group Z max. And if I rotate, this group here will be Z min, like this. So just have to do that for X and Y. Make sure I'm not getting it wrong. So this will be Y min. This will be Y max. This one here should be X max. And the last one will be X min. Okay. Okay, cool. So if we look at the model, we see that we have those boundaries. The model disappeared, but that's okay. It's just because it was hidden here, so I can reactivate it. So I have created all those geometry groups, and my geometry is now completed. right? So next step is to go into the meshing of this. So let's go into mesh. Let's create a new mesh set. Okay, so I have selected XMean, so which is not the right one. So I could select this. Let's choose this one, hexahedron IGK. And I have to select a measure for each dimension, 3D, 2D, 1D. This will be quadrangle mapping. And for the 1D, we'll use wire discretization and give it some hypothesis based on, let's say, number of segments, so local lengths probably. Okay, so if you remember, the thickness of the plate was 4, so if I enter 4, I should get one element in the thickness. And now what I need to define is some mesh groups also. But before I need to compute that, so okay. So I got the mesh of my plate. And let's create some mesh groups. Create groups on geometry. And I just need to select those groups here. Apply and close. And I have them. Now I'll do one last thing, is that now that my mesh is ready, I'll click on it and I will export it into a MED file. And well, let's just call it mesh1 dot, well, let's be a bit original, plates.med. Okay, right. Okay, and now that all of that is done, the most important thing to do is to export, to dump the study. So which means that I'll generate a Python script which contains all the operation, the geometry, the mesh creation that I just went through. So let's call that plate creation. And let's have a look. So we see that this basically appeared here. Let's open that. And you see that this basically contains everything we will need to generate this model using Python. So I will be, what I'll use in YACS will be based on all of this. So now let's go back to Salome and let's switch and go to the YACS module. Okay, so now I have not created a scheme yet. So click on the small icon to create a YACS scheme. Okay, and there is nothing in it. So the first thing to do is to create a node. And let's create input data node. So this node will only contain a few inputs. And what I'll do is that I'll create into this node, let's say that I want to set up parametrically the thickness, the length, and the width of my plate. So I'll have some output ports here. And so that will be A equal to 500, b equal to 500, because those are the basic values that I used for my first model, and 4 for the thickness, right? So I have this node created. Now let's create another Python node. So it's an inline script node. And what I'll do in this one is that it will receive and input those 3 variables. So, and instead of putting them as double, well, let's put them as double. Generally, the input should be equal to output. So A, B, and T. Okay, let's link that to this. And now it's time to do a test to see if it works. So let's go into this window and let's type, let's say, a simple Python command, which will be print A. So if you're using Python 3, usually here in this Salome Mecha 2018, it's still Python 2 which is used. So don't put print with the parenthesis, or you'll have some problems. So print A, and let's do like that: print A, print B, and print T. Sorry, there is an auto completion. Apply. Okay, so I have this. So let's just execute. Let's go into prepare the current edited scheme for run. If you don't know how to use YACS, by the way, you probably need to watch my first video about YACS, because all what I'm doing here is explained much more in detail in the previous video. So let's prepare the scheme like that, which is ready to run. Let's execute. We see it's written down, there is no error, so it works. But where is my output? Where is the print? You have to go to new scheme, right click, and there click on the YACS container log. And basically all what is executed, which within these containers, will be displayed here. So we see that the values 500, 504 are printed, which means basically that this works. This code basically works here. So now that you understand that this works like that, let's close this and go back to editing mode. So it's important you have 2 modes in YACS: editing mode and execution mode. So if you're in the execution, you cannot modify this. So make sure you, every time you execute, you have to close this and come back. Okay, so now we'll paste some code here. And what kind of code will we paste here? Well, I will paste the code that I obtained from the dump Python in the previous step, right? So if I go back to my Python file that I have, so let's not be greedy. Let's just consider the geometry creation first. So let's take all this part of the code here, copy that, and basically paste this here, right? And yeah, and now what I can do is that instead of, so if I go down in the script, when is the box actually taking some dimension? It is inside this function, make box dx, dy, dz, and you see you have the 500, 504. So instead of putting those 3 values here, I'm just going to replace by A, B, and T. Right. And now I would like to do something more than that. Well, okay, first let's try if it works before doing something more. Right. So let's don't forget to save your scheme. So let's okay, let's call that my plate generator, and it will be .xml. Save. So you always have to save separately the XML file of containing your scheme and your HDF Salome. So make sure you save both every time. Okay, and let's try to see if it works. So I'm in execution mode. Let's execute, and it says that it's done. So it should be working. How do I know if it works? Let's go to my geometry module. And you see that now I have a second box here. I had only one box, right? So I have created here a second box. So if you're not convinced that this is coming from YACS, let's do some simple change. So again, let me close this execution mode. Let's change those variables. So let's take, I don't know, let's change the thickness to 12 or something like that. Okay, let's execute that again. And yeah, I'll even do something more. I'll just change the name. So if you go back in the script, there's probably somewhere where it's called, oh, okay, it's maybe a bit too much of a hassle to change the name, because I'll have to, oh no, wait, box 1, propagate box 1. Oh no, it's okay. So you see here, instead of box 1, I'll call that box 2. That's all. Okay, let's execute. And let's come back to my geometry module. And if I'm lucky, yeah, I have a box 2 here. And you see that the thickness is different. Thickness is much more, well, it's basically 12 millimeters. So you see that you can, like that, you can control your geo module, your SMesh module from YACS. And that's what I'll be using to generate this automation. Now let's add the second part of the script, which is considering the meshing, right? So let's add, let's close this mode. It asks me to save every time. Okay, that's fine. Okay, close my script. That's why you have to be sure your scheme is always saved. Okay, anyway. So I'm still in. Okay, this is the edition mode, right? Okay, so let's add a new Python inline script node. And by the way, it's cool to give them some names. So this will be geom node. So I can call it like that. The geom node, and this one will be mesh node. I forgot to apply to. You have an apply button here to change the name. Okay, and what I need to do is basically the same in this node here. I have some Python code to paste, so I'll just take my my dump Python file here, coming from SMesh. I'm taking that. So I don't need the last instruction, I think. So I'm taking this one, I'm pasting that here. And now the important part is, okay, those two nodes are actually independent. So the variable which have been generated here do not automatically transmit to my mesh node. So what I need to do is to create some outputs from the geom node, which will have those variables, that are reused by my mesh node. So how do I know which objects are reused here? Well, that's, you have to look a bit carefully to that. So if you look at the kind of objects which are created here, so you have, let's have a look. It takes a bit of time to understand how this works, but you have basically a study, which is some Python object which contains the Salome study that you defined. You have then you have the various objects you create here. So if you think about it, the box is an object, the volume is an object, the different groups, zmin, then bax, the 6 groups here are all objects. This is, you don't actually need this part, I think. This is just to display within the graphical interface. If you don't want your model to be displayed in the interface, you don't need that. And if you see, for example, this variable, the study, it's actually defined in this part of the script, the study. So if you will need to transmit that from this part to here. You will need also the box. You will need the various geometry groups. And I think that's more or less what I will need. And the volume. Yeah. So let's do that. Let's go into my geometry node here. And let's create my output ports. So what kind of type should I choose here? Well, those are Python objects, so you should use this type PyObject. And basically, so let's create 6 for the 6 geometry groups first. Plus the volume. Okay, let's change the name. Xmin, Xmax, Ymin, Ymax, Zmin. Let's make it a bit bigger. Zmax and volume. And probably I'll need, so I need the study also, I told you. Let's have a look, the study. So yeah, the study like this. If anyway I'm missing some variables, well, it will not work, so I will see immediately if I'm missing something. But let's, and now I need to redefine that as an input here. So I know that's a bit hassle, but that's, so you could, by the way, you could put all the code in one node as well, but I'm separating both so you see a bit how it works. Xmin, Xmax, Ymin, Ymax, Zmin, Zmax, volume, and last one is the study. Okay, and let's link them. Okay, and now let's save that. By the way, I didn't save my HDF file, bad practice. Save my XML file. Okay, let's see if this works or not. Okay, and here I'm getting an error. So when I get an error, again, the error is displayed here, or you could, like that, go in the YACS log. Yeah, this one doesn't show actually the error, but this one shows box1 is not defined. So it means basically I forgot to pass the box1 variable. So I need the box1 too. Box1 and okay, let's leave that. And now let's run again. And now it works. So if I go into here, you see that I have my plate.met that has been generated. Let's try to delete that. And let's try to run again this to see if it's automatically regenerated. And yeah, you see it appears again. So it's basically generated here by the script. I have created this automation to generate this. So why is it useful to create this? Because I can basically add some variables. So if I wanted to, let's say, control the size of the mesh. So you remember that I meshed with dimension of 4. So which in the script is defined here, regular local length 4. So let's say that I want to make a variable from this. So, and let's add a new import double here, which will be called mesh size. And let's make a double variable here called mesh size. Let's link this to this. Don't forget to initialize this value here. So double click here and let's put that. So my initial size was 4. Let's put that 8. And now in this script here, I'm able to change, instead of putting 4 here and hard code the size, I can put mesh size. Apply. And let's change the name of the mesh, which is generated. Let's call that plate2.med. So the link and the mesh file name, I could also put that as a variable, by the way. Let's run again. And now if you look, you see that I have 2 mesh sets. One is plate, one is plate 2. And by the way, if I go back to my mesh module, you see that all the mesh are directly imported here as well. So I have my mesh 2, which is also directly available in this module. Sorry, I'm looking at. Yeah, this one. So you see that this time the thickness is 12, right? And that's why when I mesh with 8, it divides in 2. So I was able to create this YACS scheme. Now, what is this XML scheme? If you could actually open it and have a look at the way it looks. It looks a bit like HTML actually. So because XML is basically some kind of HTML, or you can say it's more the reverse. HTML is some special kind of XML, with and XML has some special names which are not into HTML. So this is the format which is saved, and you can exchange this kind of automation schemes. So if you give this scheme to someone else, you can import it in YACS and can generate like that plates. And that's all for this video. So in the next video, I'll show you how you can create an Aster study based on that, and how you can add that to your little script to not only create the geometry parametrically and the mesh, but also how you can add Aster into this to do the simulation and access the results of the simulation, all that automatically. So this will be for the next video. So if you like this video, make sure you follow my channel and you like the video. Thank you very much for watching, and let me know if you have any comments or things you want to know.